Hello friends, welcome to our channel Brain Alive. Friends, we will study band theory in solids in this video. Band theory easily explains the difference between semiconductors, conductors and insulator. We will take the example of silicon. Silicon is a solid and it is a semiconductor. Electron configuration of silicon is this. It has atomic number 14. Its configuration, electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p2. It is the atomic structure of silicon. The first cell of silicon is it has 2 electrons. First cell of any atom can have only 2 electrons. It is also the K shell or the K orbit. It has only one suborbit S. It has only one suborbit S. This is the subshells or suborbit, and this is the main orbit. K can have only one orbit S, and it can hold only 2 electrons. Then next shell is the L shell or the next energy level. This is the lowest energy level. Yani ki first one is the lowest energy level, and next one L shell can have 8 electrons, total number of 8 electrons. It is also called L shell. It has 2 subshells S and P. S, as we know, can hold only 2 electrons, and P can hold maximum of 6 electrons. So L orbit can hold total number of 8 electrons. Then this is the third energy level. This is the highest energy level or the outermost level. It is the highest energy level. It can also be represented by M. It has 3 subshells S, P and D. In this we have 2 electrons in S subshell, and in P subshell we have only 2 electrons because its configuration is 14. So the last cell consists only 4 electrons. The electrons in the last cell are also called valence electrons. These electrons are loosely coupled to the nucleus of the atom, and the electrons in the first shell are tightly bound to their nucleus. So electrons in the last cell, means outermost cell, have the highest energy level and can easily leave this cell or this orbit and can take part in the conduction of the current. Now we'll see the energy levels. This diagram is the energy level of single isolated atom. This is the first cell corresponding to the K level or corresponding to the first orbit. Because this is completely filled, so it is shown by solid line. And the next shell, next energy level is second level. This is corresponding to L level. This is S and P sub energy levels or the subshells. These are also completely filled. The next energy level is third energy level. This is corresponding to M level. This energy level is S is completely filled, but P is not completely filled. P is partially filled because it has only 2 electrons, and D is unoccupied. And the other energy bands and the other levels also don't have any electron. So this is the energy level of single isolated atom. It means influence of any other atom does not affect this atom. So energy levels, these are the energy level, means these have single energy levels in isolated atoms. Now we will consider solid as a whole. We are considering silicon. Let this silicon bar has 200 atoms. So there will be 200 K shells because there are 200 atoms, and the energy of these K shells will differ slightly, extremely in slight amount due to their charging environment. So these energy levels of K shells, of these 200 K shells, are very close to each other and appear to merge into each other. So we represent these by bands. So this is the first band. This is also completely filled, and this is the second band. This is also completely filled, but the third band is partially filled because it can contain 18 electrons, but in this case of silicon it has only 4 electrons. So this is partially filled, and above this is unoccupied bands, means these band does not have any electrons. So this is the atomic energy levels of solids. Now, on the basis of these energy bands, we will differentiate between insulators, semiconductors and conductors. This is the energy band diagram of insulator. This is the valence band and this is the conduction band. First, we will tell you about what is conduction band. In case of certain materials like metals, if we provide some potential difference, some of the electrons leave their valence band and they move freely into the crystal lattice. This free space where they are moving in the crystal lattice is represented by conduction band. In conduction band, the electrons are free to move anywhere in the crystal lattice, anywhere in this band or anywhere in this band. Electrons in this band are responsible for current conduction. If there is no electron in this conduction band, then that material is not a good electrical conductor. Now we will discuss insulator. In case of insulator, there is a large forbidden gap between valence band and the conduction band. If we provide some potential difference across the insulator like glass, no electron will be able to move from this valence band to that conduction band. If we provide very high energy to the insulator, there may be some of the electrons that may jump to the conduction band. So some of the materials are insulator at room temperature but are good conductors at very high temperature or when we provide them very high electrical field. So that is the reason. In case of insulator, so there is large forbidden gap. This is the main point that differentiate it from conductors and semiconductors. This is the semiconductor. In case of semiconductor, there is a small forbidden energy gap between valence band and the conduction band. In case of germanium, this forbidden gap is 0.7 electron volt. And in case of silicon, it is 1.1 electron volt. This forbidden energy gap is measured in electron volt. At room temperature, this conduction band is totally empty. There is electrons in only valence band. But when we increase the temperature or provide some potential difference to the semiconductor, some of the electrons are able to move and jump to this forbidden energy gap and move to the conduction band. But the energy we are providing must be equal to this forbidden energy gap. Only in that case electrons will be able to move from this valence band to the conduction band. So there is a small energy gap, and in case of insulator this is a large energy gap. This is the difference between these two, insulator and semiconductors. Now we will discuss conductors. In case of conductor, there is no energy gap between valence band and conduction band. Even there is overlapping between these two bands. So all the electrons that are in the valence band are free to move in the conduction band. So metals are called good conductors because they have overlapping between valence band and conduction band. So this is the difference between these three materials on the basis of band theory. I hope you understand the concept. If you like the video, please click the like button and subscribe the channel. Thanks for watching the video.